Welcome to the video on polynomial functions. A polynomial function is a function where all the terms have non-negative integer powers of x. So you would have some coefficient times x to some power. So it could be to the 10th power and then to the 9th power, x to the 8th, 7th, all the way down to your constant, because that would be times x to the 0 power. We're going to learn about the different ways to find zeros or roots of polynomial functions and how to find their factors. So over here is an example of a polynomial function, and here is where the zeros or the roots would be. There are some local minimums, a local maximum, and then our maximum is infinity, and then here this is also our absolute minimum. So an important thing to know how to do to find your zeros of polynomial functions is synthetic division. So for synthetic division, I'll explain how it works using this example problem here. So it says 2x cubed minus 3x squared minus 11x plus 6 divided by x minus 3. So you would take some polynomial function and divide it by a linear binomial. So to do this, you would put the coefficients in the first row. So this 2 goes down here. We have our negative 3 here, our negative 11 here, and our positive 6 here. We'll bring down the first coefficient. So we brought down the 2 to here. And we're going to be multiplying by the 0 of our linear function. So our 0 of this binomial would be when x is 3. So that's why we have our 3 here. So we'll do 3 times 2, which gives us 6. So we'll add that to the next coefficient. So negative 3 plus 6 gives us positive 3. And then we'll do 3 times 3 to get 9. Negative 11 plus 9 is negative 2. Our 3 times negative 2 gives us a negative 6. 6 minus 6 is 0. So then we'll convert our result into an expression by adding back the variables or exponents starting with 1 degree lower than our original function. So our original function was a cubic function, so we'll go down to a quadratic function. So we'll have our 2x squared plus 3x minus 2, and then this final number here is our remainder. We'll learn more about what this remainder means in the next couple slides. So here is a polynomial theorem. It's the remainder theorem, which says if you divide a polynomial f of x by a linear expression x minus a, the remainder will be f of x at a. So f of x divided by x minus a equals an expression with a remainder f of a. So this says find f of 8 if f of x equals x to the 4th plus 3x cubed plus x squared minus 24x plus 2. So we're going to do synthetic division. So we're going to be dividing it by x minus 8, because our remainder will then be our f of 8. So we'll take our coefficients and put them in here for our synthetic division. So we have a 1x to the 4th, 3x cubed, 1x squared minus 24x plus 2. So if you had a term that was missing, for example, if we didn't have an x term, we would need to put a 0 in here instead of our negative 24. So you need to make sure that you have placeholders, even if the coefficient is 0. So our a value is 8. We'll start by bringing down our 1. 1 times 8 is 8. So 3 plus 8 is 11. 11 times 8 is 88. 1 plus 88 is 89. 89 times 8 is 712. Negative 24 plus 712 is 688. 688 times 8 is 5,504. 5,504 plus 2 is 5,506. So this here is our remainder. So f of 8 equals 5,506. So this is another way to figure out f of 8 as opposed to just plugging in 8 here for x into all of these points. We have two more polynomial theorems. Our rational roots theorem says a rational zero of a polynomial is p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. So in terms of this example down here, we have our leading coefficient, which is 2, and we have our constant term, which is 12. So p is a factor of the constant term. So for 12, our factors are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. And our factors of 2 are plus or minus 1 and plus or minus 2. So a rational zero could be any form of one of these numbers over one of these numbers. So when you're trying to figure out a factor and you don't have an idea, these are some numbers to start with. And it's typically best to start with the easiest ones. So you could do positive 1 or negative 1 as one of your first values for a to figure out if they would be one of the factors. So our factor theorem says if you divide a polynomial f of x by a linear expression x minus a and the remainder is 0, then x minus a is a factor of f of x. So when you get a remainder of 0, then you know that your x minus a is one of the factors. So we'll try this example, and we'll start with a factor of x minus 1. So our a value will be positive 1. So we'll use our synthetic division. We have 2, negative 4, negative 10, and 12. And then we're dividing it by 1. So we'll bring down this 2. 2 times 1 is 2. Negative 4 plus 2 is negative 2. Times 1 is negative 2. Negative 10 plus negative 2 is negative 12. Negative 12 times 1 is negative 12. 12 plus negative 12 is 0. So you can see here our remainder is 0. So that means that x minus 1 is a factor of this f of x. And it would be x minus 1 times this when we turn it back into an expression. So our original was an x cubed, so this would be 2x squared minus 2x minus 12. So it would be x minus 1 times 2x squared minus 2x minus 12. We can factor 2 out of here, so we'd have 2 times x minus 1 times x squared minus x minus 6. So for this quadratic one, we can use our rational roots theorem to figure out which things multiply to negative 6 and which things multiply to 1, because those are our constant terms and our leading coefficient. So negative 6 could be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. And 1 would just be plus or minus 1. So we could try to see if x minus 1 is a factor again. So we would have our coefficients, which are 1, negative 1, and negative 6, divided by a 1. We'll bring down our 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 0 times 1, 0. Bring down our negative 6. So here we have a remainder of negative 6, which means that x minus 1 is not a factor of our x squared minus x minus 6. So we'd have to try something else. You could keep trying things over and over, or because we know how to factor quadratics, we can figure out easily that this is going to be x minus 3x plus 2. So this would become 2, x minus 1, x minus 3, x plus 2. So that would be our fully factored form of f of x. But all that this question asks for is a factor, so you could have just been done at this point where we found x minus 1 is a factor. Next, we have some information regarding our roots of polynomials. So for a polynomial equation, the sum of r equals 0 to n of a sub r times x to the r equals 0. The sum of the roots is negative a sub n minus 1 over a sub n. So this a sub n minus 1, this is the coefficient of the second term. And this a sub n is your coefficient of your first term. So you would take negative coefficient of second term over the coefficient of the first term, and that would give you the sum of your roots. Then we can find the product of our roots by taking negative 1 to the n of a sub naught over a sub n. So this would be negative 1 to the n of your constant term over your coefficient of your first term. And it'll be multiplied by a negative if it's an odd degree polynomial. Here's our first IB practice question. It says, if f of x equals 3x squared plus 12x plus c divided by x minus p has a remainder of 28, what is the highest possible value of c? So to solve this problem, we need to know our remainder theorem, which says that f of a equals your remainder. So in this case, this would be your a value, p. So if we plug in p for x, then we'll get a result of 28. So 3p squared plus 12p plus c equals 28. So we can solve this equation for c by subtracting 3p squared and 12p from both sides. So we get that c equals negative 3p squared minus 12p plus 28. We can factor out a negative 3p from our first two terms to complete the square. So we get negative 3 times p squared plus 4p plus 28. To complete the square, we need this value divided by 2 squared added in here. So 4 divided by 2 is 2, and 2 squared is 4. So this is going to equal negative 3p squared plus 4p plus 4 plus 28, and then we'll subtract negative 3 times 4, because we have our negative 3 plus 4 that we've added here. So this equals negative 3 times p squared plus 4p plus 4 plus 28 plus 12. So we can simplify this even more to negative 3 times p plus 2 squared plus 40. So c equals negative 3 times p plus 2 squared plus 40. So this will be maximized if p equals negative 2, because then c would equal negative 3 times negative 2 plus 2 squared, so times 0 plus 40. So c would equal 40. And we can double check that this is true by taking our f of x equals 3x squared plus 12x plus 40, and our factor of x minus p, so x plus 2. So we'll divide f of x by x plus 2. So we'll put our negative 2 on the outside, and then we have 3, 12, and 40. We'll bring down our 3. 3 times 2 is negative 6. 12 minus 6 is 6. 6 times negative 2 is negative 12. And 40 minus 12 gives us 28. So here we have our remainder of 28. So we know for sure that 40 is a possible value, and we found out through this math that it's going to be our maximum possible value. So c equals 40. So here we have our second IB practice question. It says, given the equation 72x cubed minus 108x squared minus 10x plus 7 equals 0, A, find the sum and product of the roots. So we'll start with the sum. Our sum is going to equal our negative second coefficient, so negative 108, divided by our first coefficient, 72. So that gives us 108 over 72, which simplifies to 3/2. So our sum equals 3/2. Our product is going to equal our constant term, 7, over our first coefficient, 72. And because it's an odd function, we're going to put a negative in front. So our product is negative 7 over 72. Part B says, the roots are 3 terms in a row from an arithmetic sequence, a minus d, a, and a plus d. What are the roots? So we'll start by finding the sum of the roots. So you have a minus d plus a plus d. And that has to equal your sum, which is 3/2. Our negative d and positive d would become 0. So we have 3a equals 3/2. We'll divide both sides by 3. So we get that a equals 1/2. Next, we'll deal with our product. So our a times a minus d times a plus d should equal our product, which is negative 7 over 72. Our a minus d times a plus d becomes a squared minus d squared. That times a equals negative 7 over 72. We'll plug in a. So we have 1/2 times 1/2 squared, so 1/4, minus d squared equals negative 7 over 72. We'll multiply both sides by 2. So we'll get that 1/4 minus d squared equals negative 7 over 36. We'll subtract 1/4 from both sides to get negative d squared equals negative 7 over 36 minus 1/4. We'll multiply our 1/4 by 9 over 9 to get a common denominator of 36. So we get negative d squared equals negative 16 over 36. We'll multiply both by a negative 1 to get positive d squared equals 16 over 36. So d will equal the square root of 16, which is 4, over the square root of 36, which is 6. So that equals 2/3. So now we can find our roots. We have our a minus d, a, and a plus d. So a minus d is 1/2 minus 2/3. We'll have a common denominator of 6. So 3/6 minus 4/6 is negative 1/6. Our a value is 1/2. And then our a plus d is 1/2 plus 2/3. So 3/6 plus 4/6, which gives us 7/6. So our roots would be negative 1/6, 1/2, and 7/6. And this d, it's going to be plus or minus 2/3, but because we're adding d and subtracting d, it's going to come out to be the same roots. In summary, a polynomial function is a function where all the terms have non-negative integer powers of x. So f of x equals a sub n times x to the n plus a sub n minus 1 times x to the n minus 1, and so on until a sub 1 times x plus a sub naught. Synthetic division can be used to find factors and function outputs. The remainder theorem says that if you divide a polynomial f of x by a linear expression x minus a, the remainder will be f of x at a, or f of a. The rational roots theorem says a rational zero of a polynomial is p over q, where p is a factor of the constant term and q is a factor of the leading coefficient. The factor theorem says if you divide a polynomial f of x by a linear expression x minus a, and the remainder is 0, then x minus a is a factor of f of x. The sum of the roots of your polynomial is negative a sub n minus 1 over a sub n, and the product of the roots is negative 1 to the nth power times a sub naught over a sub n. That's all for this video. Thank you for watching.